Hi and welcome back. In the previous lecture, we created a simple circuit in which an LED blinked on and off. The Arduino sketch that drove the circuit simply wrote a high or low value to the digital output pin 9, and the LED was turned on and off accordingly. What we want to do now is to make the LED not to blink but to fade on and off. We'll be keeping the exact same circuit, and we're only going to make small changes in the sketch to make these happen. So let's go and have a look at that. So the only change we have in this experiment is really in the sketch. So the circuit on the breadboard is exactly the same. So let's go ahead and bring up the fading LED example from the Arduino IDE. So bring up the Arduino IDE, then go to File, Examples, Basics, and click on Fade. Here it is. So what you have here is pretty much the same components as the blinking sketch, except that now we've got a little bit more code to take care of the fading instead of the blinking. Don't worry about what's in this for now. I'm going to upload it and see what effect it has on the LED. Then we'll explain how it works. So let's upload it. There you go. So the LED will fade instead of blink. It's a much nicer effect, isn't it? Alright, so how is this happening? Let's have a look. First, again, we define the pin where the LED is connected to, and then we set a couple of variables. This is the starting brightness, so we've got a variable that controls the brightness of the LED. So that's a number that describes that. And then this is our fade amount, which basically controls how fast the LED should fade on and off. You can experiment with this. For example, if I make this 1 instead of 5 and re-upload the sketch, see what happens. There you go. So the LED now fades on and then fades off slower than it did when the fade amount was set to 5. See how slow it is? Very slow. So that's the effect that this thing has here, this variable. And the setup method, not change. The mode for pin number 9 is still going to be output. Now in the loop, the biggest difference is that instead of using digital write, we now use analog write. So with analog write, we pass the LED number, pin, which is still going to be 9, and a number that describes the brightness. And this is a number between 0 and 255. That's as high as it goes. So analog write uses a feature in the microcontroller called pulse width modulation. And with pulse width modulation, the microcontroller in a way emulates the creation of an analog signal. Don't worry too much about this for now, because I've got a lecture coming up where I explain in a lot of detail how PWM works. But for now, just remember, instead of using digital write, we use analog write to simulate creating an analog value. We send that value to LED pin number 9, and we pass a number from 0 to 255, and the larger the number is, the brighter the LED is going to be. If this number brightness is 0, then the LED is going to be off. Right, now in the next line here, what we're doing is that we're controlling the brightness by looking at what the brightness of the LED was previously and adding a little bit to it. So for example, if the brightness of the LED happened to be 190, then to that we are going to add another, in this case, 1. It's going to become 191. Right? If you had 10 here, then if the previous brightness was 190, then the new brightness is going to be 200, and your LED accordingly is going to light up faster than it did previously. Now, here, what we're doing is to check to see if the LED has reached either limit, either has gone completely turned off or it's gone completely turned on. So 0 is obviously completely off, 255 is completely on. And if that happens, or either one of these two things happen, that's what that symbol means here. It is an OR. Then we just switch the fade amount to its exact opposite. So if fade amount in the beginning was +1, then the new fade amount is going to be -1. So that means that if the LED has reached maximum brightness at 255, then at the next time we go through the loop, the LED will start fading by, instead of adding a fade amount, subtracting a fade amount. I hope that makes sense. So feel free, of course, to experiment with this line here to see how it behaves. Finally, we introduce a delay. This is going to be 30 milliseconds. Again, you can play around with this number to see what the effect is going to be in the speed of the fading. So if you make the delay smaller, then the fading is going to be going through the on and off states much faster. If you make this delay larger, then the fade is going to take longer to complete each cycle. Right, so that's all there is to it. You can strongly recommend that you experiment with this little script and just make some changes. Change the delay number, for example, here. Change the fade amount. Even change this code here to see what happens, for example, if you comment it out. So you can comment bits of code out, then re-upload your sketch to see what the effect is going to be. So what I've just done now, basically, once my LED goes to its brightest setting, it's just going to stay there until basically it recycles. So you can see that the fading always goes from low to high. It never goes from high to low. That's an interesting effect. I wonder if any of you will be able to explain why this is happening. So you notice how once the LED becomes as bright as possible, so it reaches a 255 value, and it switches off very, very quickly. That's not a fade off, it's just a switch off. And then it starts fading on again. If any of you can figure out why this is happening, let me know. I'd be very interested to know. Okay, so there you have it. You can just simply make a little bit of a change to your sketch and the same hardware can behave differently. With this example, we conclude the lectures in the introductory part of the course. In the following lectures, we'll look at various sensors that will allow your Arduino project to take measurements from the world around it. But before that, I'm going to give you a little introduction in the Arduino language itself, some basic things that are going to help you later on. See you in the next lecture.